Okay, so hi everyone. This is the fourth week of the course Fluid and Particle Mechanics. So, in this week, we will mostly, because the theory sections was very clearly discussed in class, I don't think there will be any doubt regarding the uh, theory based on the dimensional analysis and the scaling analysis, particularly the Buckingham pi theory and all. So instead of going into the theory again, what we will do, we will try to solve the assignment problems. Okay, so let me solve the assignment problems one by one, okay, which might help you in solving the assignment from your end. Okay, so okay, so let me then solve. This is, I will call as question number 1. Okay, so it says, as you can see, question number 1, assignment 4. Yeah, as you can see the question, it says that the laminar flow through a pipe is unstable at high Reynolds number. Investigations indicate that Reynolds number for transition to turbulence is approximately, so it's saying the Reynolds number for transition to turbulence, let's say I'll call about as Reynolds T, transition to turbulence is equal to 2300. Okay, in a circular tube, approximately 2300 in a circular tube, if the Reynolds number is calculated based on the diameter of the pipe, so Reynolds number is calculated based on the diameter of the pipe, the average velocity of the fluid. Okay, so it is average velocity of the fluid and the diameter of the pipe, so D, and let's say average velocity of the fluid is U bar divided by nu. Nu is the kinematic viscosity of the fluid. If D is equals to 20 centimeter and the fluid is kerosene at 20 degrees Celsius, which has a dynamic viscosity of 2.7 into 10 raised to minus 6 meter square per second, find the volumetric flow rate in meter cube per hour that causes the transition. That's a very interesting question. Okay, so what is given? So here the one mistake in the questions is that it says a dynamic viscosity, but it will be a kinematic viscosity. Okay, because the unit is meter square per second. The meter square per second is the unit of kinematic viscosity, not the dynamic viscosity. So fluid is a kerosene, so the fluid is given as kerosene at 20 degrees Celsius, and kinematic viscosity nu is equal to 2.7 into 10 raised to minus 6 meter square per second. Okay, fine. So D is the diameter of the pipe. It is given that D is equal to 20 centimeters. Okay, so it is 20 into 10 raised to minus 2 meter. Okay, Fantastic. So what we are asked to calculate, we are find the volumetric rate in meter cube per hour that causes the transition. Okay, so so these are the data which I put it here for your benefit. Now, so Reynolds number is based on this. So what is the average velocity? So I have, so that means that causes transition. That means I have to consider that the Reynolds number is 2300. Okay, so my RE is equal to d u bar divided by nu. That implies u bar is equal to RE nu divided by RE nu divided by d. Is that fine? RE nu divided by d. Okay, so volumetric flow rate, Q is equal to cross sectional area pi by 4 d square into u bar. Am I right? So then I have to just calculate it. So Q is equal to pi by 4 d square into RE nu by d. Fine. So what is this? So it is pi by 4 RE nu d. Okay, so it is pi by 4 RE nu d. Is that right? I don't think there is any confusion in this. Now we need to just put the data and get it done. Okay, so it's a very simple problem, as you can see. So that means Q pi by 4 RE is 2300 into what is the value of nu? Nu is 2.7 into 10 raised to minus 6. Okay, into d. D is equals to into 2 into 10 raised to minus 2. Sorry, 20 into 10 raised to minus 2, 20 centimeters. So it is 20 into 10 raised to minus 2. Is that right? Fine, right? What is this coming? If I do that, it will come something around 0.000975 meter cube second inverse. Okay, so what is this value in meter cube? What is this value in meter cube per hour? So you need to multiply it by 3600. Okay, so if you do that, it will come around 3.51. It will come around 3.512 meter cube hour units. Is that fine? So that's all about the question number 1. I think there is no confusion regarding it. Am I right? Okay, so then let's go to question number 2. So this is all about the question number 1. Now we'll go to question number 2. So what it says, question number 2 says, determine the dimension of the following combination of variables. Each symbol has the usual meaning. If that square bracket denotes the dimension of the enclosed quantity. Which among the following is correct? So let me first write it down, the different quantities which are given. In A it's given rho dou u dou t. In B it's given dou p dou z. Okay. In C it's given rho cp into dou t. Fine. In D it is the volume integral. Okay, it is the volume integral. Let's say it is V. Volume integral rho dou u dou t into dx dy dz. As simple as that, am I right? Fantastic. So we need to calculate the dimensions of each of these quantity. Okay, and then we'll look for the options. So you have to calculate the dimensions of each of these quantity, and then we have to look for the options. Okay, so here I wrote the each of the quantities. Now let me write down the dimensions of each of this quantity. Okay, so first let me so what is the dimension of rho? So its unit is kg per meter cube. So m L to the power minus 3. Am I right? Dimension of velocity meter per second, L t to the power minus 1. So what is dimension of rho dou u dou t? So there is a 1 by t, so it is t to the power minus 1. Am I right? So what it's coming ultimately? It is m, then L to the power minus 2, t to the power minus 2. Fine. M L to the power minus 2, t to the power minus 2 is the dimension of the first quantity. There should not be any confusion about it. What is the second quantity? Second quantity is the dou p dou z. Okay, what is the dimension of, so this is the dimension of A. Let me write it here as, so this is A fine. The second quantity is the dopey dosette. What is the dimension of P? Pressure P. So it is Newton per meter square. Okay. What is Newton? Newton is equals to mass into acceleration. So it will have something like this. So Newton per meter square. Newton is the mass time acceleration. Okay. Am I right? Newton is mass time acceleration. Newton per meter square. Mass time acceleration is the force into by meter square is equals to L to the power minus 2. So what it's coming? It's coming as m L to the power minus 1 t to the power minus 2. Am I right? So what is the dimension of dopey dosette? There is a z, so it will be this m L to the power minus 1 t to the power minus 2 into L to the power minus 1, as simple as that. Okay, so the dimension of B, which is dopey dosette, is this m L to the power minus 2 t to the power minus 2. Okay. So I can see that these two dimensions are same, and the same thing you can see in the Navier-Stokes equation. The right hand side, sorry, in the left hand side of the Navier-Stokes equation, it is rho dou u dou t plus the convective acceleration term is equals to pressure gradient term plus the viscous forces. So the dimensions in both the dimensions of both the sides should be equal. So that's why the rho dopey dosette term, sorry, rho dopey rho dou u dou t will must be equal to the pressure gradient dopey dosette. That also we can see from here. Now the next one is the rho Cp into dou t, rho Cp into dou t. Okay, rho Cp into dou t, am I right? Yes. So what will be for this? So for this, let's see. So what is the rho we know. What is the unit of Cp? Joule per kg Kelvin. Am I right? The Cp is equal to Joule per kg Kelvin. Okay. So dimension of Cp. So its unit is Joule kg inverse Kelvin inverse. Okay. So what is Joule? Newton meter. Am I right? Joule is the Newton meter. So its dimension is Newton is equals to mass into acceleration into meter L, right? This dimension m to the power minus 1 and dimension of this will represent theta as the temperature. Theta to the power minus 1 will denote theta as the basic dimension of temperature. So what is coming ultimately? So it is Newton meter, ml to the power minus 2 into L. So this is coming as, so dimension of Cp is, so there will be no m. Am I right? Yeah, there will be no m in this, so it will be cancel, there will be L square, so it's L square t to the power minus 2 theta to the power minus 1. Am I right? L square t to the power minus 2 theta to the power minus 1. Fine. So then what is the dimension of rho is equals to kg per meter cube, m L to the power minus 3. Cp is equals to L square t to the power minus 2 theta to the power minus 1. Then the t is theta and this t is t to the power minus 1. Am I right? So what is this coming? So it is m, then you have L square and L to the power minus 2. M L to the power minus 1. Then here you have t to the power minus 2, you have t to the power minus 1. So it's t to the power minus 3. Am I right? It's t to the power minus 3. Okay. So m L to the power minus 1, T to the power minus 3. Theta is cancelling out. Yeah. So I guess this is the answer. Okay. Fine. ml to the power minus 1, T to the power minus ml to the power minus 1, T to the power minus 3. Yes. So dimension of C, that is rho Cp temperature transient term in the energy equation. This is the temporal term in the energy equation. Okay, is this is m L to the power minus 1, T to the power minus 3. That's all. And the last term which is remaining is, so we have, so it is the like the volume integral of this term. So what will be this, the volume integral of this term? So this was per unit volume. If I multiply it with volume, that's all, right? So that means the unit of term 4 will be the unit of dimension of D, which is volume integral of rho dou u dou t into this is the rho dou u dou t into dx dy dz. Is what is that, the first term is this. These will be multiplied with L cube, the volume. So it will be ml t to the power minus 2. It will be ml so it is the unit of dimension of what is ml t to the power minus 2, force. As simple as that. Yeah. Now go to the options. Let's see which options are correct. What the options given? Options are, of course, A is equals to C. I can find. Sorry, A is equal to B. There is no doubt about that. Where is A is equal to B? A is equal to B is there. Okay. So A is equal to B. There are only two options. A is equal to B equal to A is equal to B equal to C. No, that's not correct. Okay. A not equal to B equal to C equal to D. No, that is also not correct. So the correct option is probably this. A is equal to B, but C is not equal to D. Okay. A is equal to B, but C is not equal to D. Probably this is the correct option. So the correct option is that dimension of A is equal to dimension of B, comma, dimension of C is not equal to dimension of D. This is the correct option. Okay, so the correct option is this. Correct answer. What is the options number? Options number, I think there is no options number here, but I think the answers is something different, so you need to check that then. But as far as my calculation, it is the right answer. A is equal to B and C not equal to D. Okay, fine. So now we will move to the next question. So okay, so the question number 1, question number 2 is perfectly fine. Now next we will move to the question number